this video, I will show you how to use the Azure Natural Language Understanding service inside Unreal to extract information from Neo4j. Natural Language Understanding provides a more flexible way to interact with respect to the previous example, where we use simple automatic speech recognition. To work with Natural Language Understanding, first you have to create an application inside the Language Understanding Intelligence Service, or LUIS, that Microsoft provides. I'll put a link in the description about how to create an application in LUIS, and I'll concentrate on how to set up the information that is required to manage our conversational agent. The main things that you have to consider when creating a domain for your application are these: entities and intents. Let's start with entities. We know that in our database there are two different kinds of items that we're interested in. There are actors and movies. So I created two entities, one for actor and one for movie, and both have our type list. Lists are a fixed closed set of related words along with their synonyms. So they're expected to be an exact match in the text that results from automatic speech recognition. In this case, I introduced inside LUIS the list of names that are present in the example database that we're using in Neo4j. You don't have to type this one by one, luckily, because you can import lists by uploading a file in JSON format. Let's see how we can extract this file from Neo4j. So let's jump into Neo4j now. To obtain the list of people who acted in movies, then we can use this query. So match P of type person who acted in a movie and return their name. So we obtain a list of names that are present in the database. If you click on here, code, then you can see the response in JSON format. If you simply copy this JSON, you can use whatever method you want, like regular expressions for example, to transform this JSON into the format that LUIS wants. I already did this, so let's keep talking about LUIS and Unreal. Back to LUIS, as you can imagine, inside movies, I have another list, also taken from Neo4j, containing the titles of the movies that are present in the database. This way, LUIS knows which entities can be expected to be present or to be asked from the person who is interacting with, and it can automatically detect them into transcriptions. So now let's move to intents. Intents represent the intentions of people who are using applications that are based on LUIS. In this case, we have two intents. We have getActedIn, which is the intention of asking the list of people who acted in a certain movie. And we have getActorMovies, which is the intention of asking the list of movies a certain actor was in. For each of these intents, I indicated the entity movie as a feature for the intent getActedIn, while the entity actor is a feature for getActorMovies. By indicating entities as features of intents, I'm signaling LUIS that whenever he sees an entity of type movie, this is characteristic of the intent getActedIn. Same goes for actor with getActorMovies. This way, LUIS can more easily recognize the intents with fewer examples. LUIS needs examples in order to understand what kind of requests are linked to the different intents that it has to recognize. So let's see, for example, get acted in. Here you can see a list of example phrases that ask about who acted in certain movies. You can see that Louis is able to recognize the movie entities because of the list entity that I loaded before. For example, if I want to introduce another example, I can write something like, do you know the names of the people who were in As Good As It Gets? So this is a new example that represents the get acted in intent, and as you can see, Louis was able to understand that As Good As It Gets is the title of a movie. Let's delete this so that we can use it for a test. And let's quickly check what I put into the get actor movies intent. As you can see, I have a list of questions, and in this case too, Louis was able to recognize names of actors. I am not using the none intent in this simple example because I'd like to keep things as simple as possible. But for more complex models, you definitely will need to add some negative examples, like for example, in this case, what time is it? Or what's the weather like? Something like that. Once you finish creating examples, you can train your model so that Louis starts learning from your examples how to recognize intents and entities. So let's train it now and wait for it to finish. Once the training is complete, you can test your application. Let's try with who was in As Good As It Gets. Okay, so Louis recognized get acted in with a nice confidence. The closer to 1, the more sure Louis is. And if we get the details, then we can see that it also got the entity As Good As It Gets as movie. Now we need to publish this application so that it can be called from Unreal. So let's close this and this. And let's click on Publish. Let's choose the production slot and done. Now that the app is ready, we should go into Manage, and you should take note of the application ID under the first tab here. And you should also take note under Azure Resources of the primary key that Microsoft assigns you for the prediction resource. You will need both the app ID and the primary key to call the application from Unreal. So now let's switch to Unreal and see how we can call this application from inside Unreal and query the database with the information that is now coming from Louis. Inside Unreal, I already modified the blueprint from the previous example, and I'll now walk you through it. First of all, you'll need to add an Azure NLU component instead of the Azure ASR component. You can do this by looking for it in the list of components. After you add the component, you can configure it here by putting the primary key in this field and the application ID in this field. The region is the one that you choose when you create your application in Louis, and the language is the same too. In this case, I'll be using South Central US and English US. Just put the other keys here and you should be fine. I'll remove this. Here in the begin play event, I connected the Azure NLU component and I created the NLU start function by dragging this out. As in the previous example, the plugin will start streaming the audio towards Lewis and it will automatically use automatic speech recognition before applying natural language understanding. So you don't need to perform manually automatic speech recognition in Unreal. As in the previous example, you will get the answer from Lewis after a couple of seconds of silence when you talk to the system. And as in the previous example, you get an incoming message that you can connect in order to manage responses from Lewis. Let's see how it works. So this event reports the information from Lewis after you speak into the microphone and tell the system what you want. As you can see, you get the transcription, the top intent recognized, together with the score of the recognition for the intent, and you also get an array of entities containing all the entities that Lewis recognized. To reproduce the example from the previous tutorial, in which we used parameterized queries to query Neo4j, first of all, we need to clear all the parameters so that we're sure that the map is empty. Next, we will use two different queries for Neo4j, depending on which intent was recognized by Lewis. In the first query, we get the names of the actors who acted in some movie. That should be present in the utterance. Let's assume that for the sake of simplicity. While the second one gets the list of titles in which the same actor that was named in the utterance is present. Both queries return their results in the same format as a list, and the lists, the column names, have the same name. So I renamed pname as output, and I renamed mtitle as output too. It will come in handy later. So these are the two queries that correspond to each intent. Next, depending on the intent that was recognized, the list of parameters should include either a title or a name parameter. This will be found in the entity that Lewis recognized. So here I'm assuming that the entity is always there and that it's the only one present, just for simplicity. So I simply get the first entity that is returned by Lewis, and I extract the string or entity from this object, and I put it as the value of the parameter, either title or name. From here on, everything is exactly as in the previous example, so I send the query that I set from before, I pass the parameters in here, and I call the Neo4j component. As in the previous example, we get an array of rows from Neo4j, and we want to print the list of names or the list of titles depending on what we asked. So we have a for loop that for each row gets a map of cells, and we know that the only column that we're interested in, and it is actually returned by these queries, is named output. So it doesn't matter which intent was recognized, the output will be called output. Now we need to cast the cell to a simple cell because we know that there will be only strings in there. We get the value and we print it. So let's compile the blueprint and see what happens for the first intent. Who acted in the matrix? Here's the list of people who acted in the matrix. Again, I can ask which actors, for example, appeared in Cloud Atlas. Which actors appeared in Cloud Atlas? And here's the list. So here's how you can integrate Azure Natural Language Understanding using LUIS in Unreal and combine it with parameterized queries with Neo4j to extract information in a more flexible way with respect to what happened in automatic speech recognition. In the next tutorial, I will show you how to include text-to-speech capabilities from both Azure and Amazon in order to make an embodied conversational agent respond depending on the data that was extracted from the Neo4j database.